Steel is an alloy of iron and carbon which contains about 95% of iron and less than 1% manganese and 2% carbon, and also with small amounts of sulfur, silicon, phosphorus, and oxygen. And according to the American Iron and Steel Institute, the types of steel can be categorized according to their different properties, namely carbon steel, alloy steel, stainless steel, and tool steel. And their mechanical properties can be improved through heat treatment, such as annealing and quenching. And steel is an important material for engineering and construction in the world because of its low cost and high tensile strength. Heat treatment can be applied to improve the mechanical properties of the steel. And I'll talk about the microstructure of the steel. The first one is the medium carbon steel, and it is the mild steel that contains 0.3% of carbon, and it is a typical engineering steel, and it is having the microstructure of pearlite and ferrite. And the hard pearlite gives the characteristics to the steels with a higher strength but a lower ductility, and it has a relatively low tensile strength due to the lower amount of ferrite, but it is cheap in price and malleable. The second one is the duplex stainless steel. It has a ferritic austenitic microstructure with a balance of approximately 50% ferrite and 50% austenite. And when the duplex stainless steel is melted and solidified from the liquid phase, the ferritic structure is formed. As it cools to the room temperature, about half of the ferritic grains transform to the austenitic grains, and the microstructure of this type of steel is formed. And the duplex stainless steel is having a high strength, about 400 to 500 MPa, because of the finer grains of ferrite, and this can reduce the section thickness and therefore reduce the weight. Also, it is having a high resistance to stress corrosion cracking. The third one is the steel that's under heat treatment, and this is the tempered steel. Tempering is the heat treatment that heating the quenching the steel to reform its microstructure. The martensitic microstructure is formed in the quenching the steel. The martensitic is extremely hard but also extremely brittle. This steel is virtually useless in this condition. Therefore, tempering can be used to make it useful. The quenching the steel is heated to about 200 degrees Celsius for an hour, and carbon is allowed to diffuse under the heat treatment, and many small carbide precipitates are formed. And the tempered steel is harder and tougher than the untreated steel. Also, it has a higher tensile strength and yield strength. It may due to the presence of the carbides on the grain boundaries. However, the grain boundaries carbides may also lead to the intergranular fracture, which makes the tempered steel less ductile. And the fourth one is the hot rolled steel. This steel is deformed by passing it through the rollers at the temperature over its recrystallization temperature, which is usually 1,700 degrees Fahrenheit. And there is an increase of pearlite microstructure in the hot rolled steel. And the fracture strength is having a marked increase of about 145% on the hot rolled steel. It might be caused by the absence of inhomogeneities in the structure. And in terms of the ductility, there is a remarkable improvement on the rolled steel, over 150% increase of the ductility is recorded. This improved ductility depends on the fine grain and the distribution of the perlite in the microstructure. And I'll talk about the optical properties of the steel. And firstly, the steel is having a solar reflectance of roughly 50 to 60% and with a low emittance. The reflectance and emittance of the steel depend on the smoothness of the surface and the presence of the surface oxides. For example, the corium oxides on the surface of the stainless steel. Furthermore, the steel is opaque throughout the entire visible spectrum, and the light radiation is either reflected or absorbed. However, the absorbed radiation is re-emitted from the surface in the form of the visible light of the same wavelength, which appears as the reflected light. And secondly, in terms of the infrared emittance, the wavelength range for this radiant energy is roughly 5 to 40 micrometers. In this spectrum, most of the building materials are opaque and having an emittance of 0.9 to 0.95. However, the clean and bare metals are the exceptions. For instance, the untarnished galvanized steel has the infrared emittance of about 0.004, and the general emissivity value of the different types of steel are listed in this table. And this comes to the impact of the ultraviolet light on the carbon steel. The polyester urethane top coat with epoxy primer and the epoxy top coat with epoxy primer are often used in the construction field, such as for beaches and the buildings. They are acting as a barrier to protect the underlying carbon steel from corrosion by environmental factors, such as the ultraviolet and the rainfall. However, the dissolution of the steel can happen at defect sites on the paint, or the compensating oxygen reduction may occur at the other steel surface under the paint. In the experiments conducted by Hattori and his colleagues in 2010, the top coat of the PUE coating is slightly coarse after the exposure to UV for 4,500 hours, while the primer microstructure is little damaged. And for the EE coating, the top coat is severely damaged after the exposure to UV, and the primer is also little damaged. It is expected that the UV radiation can cause a little degradation on the PUE coating, but a significant damage on the epoxy coating. And in order to protect the steel from the ultraviolet light in a better ways, the UV coating technology has been introduced. This technology is widely used in the protection and the decoration in various industries. Particularly for steel, this technology has been extended to high performance of corrosion protection in industrial applications. The relatively important environmental benefits of this type of technology is the reduction of the emissions of VOCs and the hazardous air pollutants. Furthermore, the use of UV coating technology can provide a superior performance of corrosion protection of steel. The UV coating also has a superior protection of the UVA and UVB band lengths. For example, it can absorb 95% of the UVA and 93% of the UVB band lengths. And the advantages of this technology is because of the process of the UV coating can complete within seconds, the time that's being used for curing can be saved. Furthermore, the UV cure is relatively independent of humidity and temperature conditions. It can apply on the metal surface under extremely low temperature. Furthermore, the fast cure of this technology can increase the work efficiency and enable higher quality coatings because of the eradication of the long cure periods. And this is the end of the steel part, and I'll pass the time to Sandra to talk about the aluminium.